Okay, so today we'll discuss the formative practice 3.1 in our textbook practice. Okay, question number 1. States Newton's universal law of gravitation. Okay, this is the first we learned about gravitation. States Newton's universal law of gravitation. The answer. Okay, Newton's universal law of gravitation states that the gravitational force between two bodies is directly proportional to the product of the masses of both bodies and inversely proportional to the square of the distance between the center of the bodies. Okay, this is Newton's universal law of gravitation. Okay, to remember this statement, you can also using the formula F equal to G(mm) over R squared. Okay. Or we have learned that F is directly proportional to M1, M2, and also we have learned F is inversely proportional to 1 over R squared. So based on the equation, we can write the definition of the Newton's universal law of gravitation. Okay, Newton's universal law of gravitation states that the gravitational force F is referred to gravitational force between two bodies is directly proportional to the product of mass of both body. Okay, this is a product of mass of two bodies. And inversely, so inversely here, inversely proportional to the square, to the square of the distance between the center of two bodies. Okay, this how to remember, how to remember the statement or definition for any physics concept. Okay, second, states the factor which influence the magnitude of the gravitational force between two bodies. So what is the factors?
Mass.
What's your answer?
Distance.
Mass and distance.
Yes.
Mass.
Mass. Mass of
Okay,
two
right.
bodies.
Mass of two bodies and distance. Okay, so the effect of the mass and the distance between two bodies on the gravitational force are shown in figure 3.7. Okay, so you can refer on your textbook. Okay, figure 3.7, and that page. Okay, the answer has given the gravitational force between two bodies depends on the mass of bodies. Okay, as well as the distance between them. Okay. So we have two. The first, the mass of the body, and the second, the distance between two bodies. Okay. If the mass is larger, the gravitational force also increase. Okay. If the mass is larger, gravitational force also increase or larger. But for distance, okay, if the distance decrease, what happened to the force?
Decrease.
Okay, the distance decrease, force increase. Okay, because the force is inversely proportional to the square of distance. So when the distance between the object increase, the gravitational force will decrease. Okay. Number 3. A piece of space junk of mass 24 kilogram. Okay, so we write the information, the mass equal to 24 kilogram at a distance of 7.00 times 10 to the power of 6 from the center of the earth. Okay, from the center of the earth. This is very important. Okay, from the center of the earth. Okay, that's mean this is a small capital of R equal to 7.00 times 10 to the power of 6 meter. So what is the gravitational force between the space junk and Earth? Okay. The questions needs we to calculate the gravitational force. So what is the equation of the gravitational force? F equal to
GM1 M2
GM
over R square.
over
GM1
R
M2 over
square.
R square.
okay, right. It's true. Okay, F equal to G M1 M2 over R square.
Square.
Okay, and then we substitute the value in our equations. The value of G as given 6.67 times 10 to the power of -11. M1 refer to the mass of Earth. Okay, M1 refer to the mass of the Earth. 5.97 times 10 to the power of 24. M2 refer to the mass of space junk. 24 kilogram. So divide by R. Small capital of R is the radius from the distance from the center of Earth. So R2 equal to R squared. R equal to 7 times 10 to the power of 6 power of 2. Okay. You get the final answer? What is your answer?
Yes.
Yeah.
195.04
195.04.
Okay. Anybody can give the answer? I want to write here.
190.
What?
100.
100?
195.
195.
195.04.
195.04 Newton.
Newton.
Right. This any answer? All get this answer?
Yes.
Yes. So the final answer 195.04 Newton. Okay, the unit of force is Newton.
Newton.
Okay, so mark your exercise. Okay, this substitution you get 1 mark, and first mark substitute the value into the equations. The second mark, the final answer with a correct unit. The final answer with a correct unit, and you get the second mark. Okay, any question?
No.
No.
So we can proceed to the next. Okay, we proceed to the next question, right?
Yes.
Okay, question number 4. Whether satellites orbit the Earth at a height of 560 kilometers. So this is referred to hash. Hash equal to 560 kilometer. So when we find or seen the value using the prefix, we need to convert into SI unit. So we get 5.6 times 10 to the power of 5 meter. Okay. Do you remember how to get power of 5?
Yes.
Okay. So next question. What is the value of gravitational accelerations? Okay, the needs gravitational acceleration of the satellite. Okay, so what is the formula or equation to find gravitational acceleration?
G
G
equals to GM over R square.
M over
R plus H.
okay, the basic R small letter of R square. Okay, for these situations, GM over R plus H square. Right? Do you agree with me?
Yes.
Yes.
And then we substitute. Next, we substitute our value into the equation. Okay, so G equal to 6.67 times 10 to the power of -11 times M. M is referred to the mass of the Earth. 5.76 times 10 to the power of 24 divide. Okay, capital letter of R capital letter of R is refer to radius of
Of
Earth.
Earth.
Okay, so the radius of the Earth 6.37 times 10 to the power of 6 plus hash 5.6 times 10 to the power of 5. Okay, so the final answer G equal to
8.29 meter second negative 2.
8.29 meter second a power of -2. All get this answer?
Yes.
Yes.
Okay. So if all of you get the same answer, is correct ah.
Cikgu nak tanya,
Okay, apa dia?
kalau kita genapkan jadi 30 boleh tak?
Oh, I think it's better you give to into this at least in 2 decimal places. The answer. Okay.
Thank you.
You're welcome.
Cikgu,
Yes.
kan 5.6 darab 10 kuasa 5 tu kan?
Okay.
Kalau tulis macam 50 ni, dia bukan dalam standard form.
Okay.
Bukan
Kalau
dalam
dalam
darab
dia,
56000.
oh boleh juga, tak masalah.
Okay.
Okay, yang penting important that when you sums with R and H, you get the same value lah macam tu, kan? Macam ni pun tengok kat sini power of 6, ini is power of 5. So kena berhati-hati juga semasa tekan calculator kan. Tapi tekan calculator tak ada masalah sebab dia akan memberikan jawapan yang lebih betul lah kan, tekan calculator. Cuma takut kalau main tambah-tambah direct, dia akan jadi salah lah. Sebab kat sini power of 6 dengan power of 5. Kalau belajar standard form tu dia lain sikit. Kalau nak tambah secara manual, kena pastikan kedua-dua ni mempunyai kuasa yang sama, barulah tambah secara direct. Okay, so mark 1, substitutions of the value in your equations. The second mark, final answer with a correct unit. Okay. Question number 5. Oh, it's very faster. A man-made satellites of mass. Okay, we get the mass of satellites equal to 400 kilogram. So this is a kilogram. For kilogram, we not need to convert to gram because kilogram is the SI unit for mass. Orbit the Earth with radius. Okay, R radius. Okay, ni orbiting orbiting radius equal to 8.2 times 10 to the power of 6 meter. Linear speed of the satellite. Okay, V, linear speed V equal to 6.96 times 10 power of 3 meter second power of 1, power of -1. So what is the centripetal force acting on the satellite? Okay, it needs a centripetal force. Okay, so what is the equation for centripetal force? F equal to
MV square over R.
MV square
over R. Oh, so very simple. Because the value of V is given, the value of linear speeds also given, and radius given. So we just substitute. So F equal to 400 times V 6.96 power of 3 squared divide R 8.2 times 10 to the power of 6 meter. So the final answer, Arah berapa?
Final answer 2.2383420.
2.2
2.38342 darab 10 × 6 Newton.
power of 6.
Yes.
Okay, all get this answer?
Yes.
Do you agree with this answer? Do you agree with this answer? Okay, I think 400 K times 6.96 exponent 3 power of 2 divide 8.2 power of 6. Okay. All get this answer?
No.
Yes.
No.
No.
What
No.
I get 2.363 times 10 to the power of
63.
4.
Yes.
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 263.
Okay. The final answer, the correct answer 2.363 times 10 to the power of 4. Okay. So Farah, try to calculate again.
Ya, cikgu dapat jawapan cikgu.
Yeah, okay.
Cikgu, kalau tak
Yes.
tulis standard form boleh?
Apa dia?
Kalau tak tulis dalam standard form.
Kalau tak tulis standard form, your answer 2363, right?
Yes.
Okay, boleh juga. Can. Able. Boleh, tak ada masalah. Okay, any question? Before we proceed to the next question for this exercise, the last question.
No.
No. Okay, so question number 6, the last question for this practice. Okay, figure 3.23 shows Mercury orbiting the Sun with the radius. Okay, so the radius R equal to 5.79 times 10 to the power of 10 meter. Okay. Then the period of revolutions, the period of the revolutions of T equal to 7.57 times 10 to the power of 6 second. Okay, calculate the mass of the suns. Okay, calculate the mass of the sun. Okay, which equation you need to use? We should to use.
M equal to 4 pi
Pi
square
R cube
R cube
over
over
GT
G
square.
square.
Okay. M equal to 4 pi power of 2, right? R squared, right? Over GT squared. This equation.
Yes.
Yes.
Okay, so this equation, we need to we should to find the mass of sun. Okay, and then we substitute 4 pi squared. R equal to 7.57 times 10 to the power of 6 power of 3 divide 6.67 times 10 to the power of 11 times I'm sorry. Okay, I'm sorry because I substitute the wrong value, right? Okay. The value of R is 5.79 times 10 to the power of 10. Okay, T 7.57 times 10 to the power of 6, power of 2. Okay, and then calculate by using your calculator. I give the time 5 of 2. Okay, what's your answer?
2 times 10 power of
Power of
30.
30.
Apa? The first answer?
2
Safwa, your answer?
2 times 10 power of 30.
2 times 10 to the power of
30
30. Yeah,
kg.
kg. Okay. Yang lain? Jawab apa?
Sama.
Sama.
Sama. Okay, so 2 times 10 to the power of 30 kg. Okay. Oh, patutlah salah nombor. Okay, calculator saya power of 10, power of 3. Okay. 2.2. 2.2 or 2.0?
2.0.
2.0.
0.
2.0, okay. 6.67. 7.57. Okay, power of 2. Okay. So the mark also same. Okay, first mark for substitution. Second mark for the final answer with correct unit. Okay. Okay, any question to ask for this subtopic?
No.
No.
Okay.
No.
No. No. Thank you for this. This lesson. We continue with
3.3.
3.3. Yes.